Let's learn about the distributive property. So, the distributive property is super useful. I use it all the time. You use it to simplify, use it to solve equations. It's pretty handy. You need to have it in your toolkit. So, here's an area model that shows you that the number 8 times the sum x plus 5 is the same as 8 times x plus 8 times 5. That's kind of cool. Cool. Did you know that you can use the distributive property to simplify the product of a number and a sum or difference? What does that even mean? Well, let's see. Let A, B, and C be real numbers, not fake numbers. So the distributive property says A times a sum is, you've probably seen this before, multiply through, right? Whoop, A times B plus, whoop, A times C. So here's your example. The distributive property says 2 times 1 plus 2 times 3. And let's see, let's just show that this is equal. Inside the parentheses, 1 plus 3 is 4. 4 times 2 is 8. So this side is 8. And then 2 times 1 is 2, plus 2 times 3 is 6. Does 8 equal 2 plus 6? It sure does. So how about, what if it's a sum, then times a number? Well, kind of the same thing. B times A, C times A. So does it work though? 2 plus 3, would that be 4 times 2 plus 4 times 3? Let's find out. 2 plus 3 is 5, and 5 times 4 is 20. So this side is equal to 20. Then over here, 2 times 4 is 8, plus 3 times 4 is 12, and what do you know? They both equal 20. Isn't that neato? Gee, Mr. Recorder, that's real neat. What if it's a number times a difference? Well, same whole thing. A times B, but now it's A times negative C, so minus AC. So how about some number examples? 2 times 3, minus 2 times 1. So let's check both sides. 3 minus 1 is 2, and 2 times 2 is 4. 2 times 3 is 6, minus 2 times 1 is 2. 4 equals 6 minus 2. It's amazing, isn't it? So, same thing works if the A is on the back side of the difference. And you can see here, 3 minus 2 is 1, 1 times 4 is 4, 3 times 4 is 12, minus 2 times 4 is 8, 12 minus 8 is 4. Alright, so what's the simplified form of each expression? Well, 3 times x is 3x, plus 3 times 8 is 24. So 3x plus 24. 5b times negative 7, and negative 4 times negative 7. So 5b times negative 7 would be negative 35b. And then negative 4 times negative 7, we're multiplying a negative times a negative, same sign, answer's positive, so it's going to be plus 28. Negative 35b plus 28. Alright, pause it and give yourself a chance to do these problems and push play when you're ready to see them solved. Alright, let's simplify this expression. 5 times x is 5x, plus 5 times 7 is 35. 12 times 3 is 36. Minus, we're doing positive times a negative now, minus, I'm going to do a little fraction in over here, 12 times 1/6. Well, 12 is 12 over 1, so this is going to be 12 over 6. But 12 is just 2 times 6, isn't it? And 6 divided by 6 is 1, so this equals 2. So 12 times negative 1/6t is going to be negative 2t. 3 times 0.4 is 1.2. And then 3 times 1.1c is 3.3c. All right, negative y times 2y, and then minus 1 times negative y. Negative y times 2y, negative times a positive will be negative 2, and then y times y is y squared. Here I got a negative times a negative, which is positive, so plus y. What sum or difference is equivalent to 7x plus 2 over 5? Well, you remember that dividing by a number is the same as multiplying by its reciprocal. So dividing by 5 is the same as multiplying by 1/5. So this is going to be 7x plus 2 times 1/5. And then we can multiply or distribute the 1/5 through the sum. And then 1 times, this is 7 over 1, this is 2 over 1. So this is going to be 1 times 7 is 7 over 5 times 1 is 5, 7 over 5, and then this will be 2 over 5. So this is the sum. So what sum or difference is equivalent to each one of these? Go ahead and pause and give yourself a chance. Push play when you're ready to see it. Alright, so this A is 1/3 times 4x minus 16. So that's 1/3 times 4x minus 1/3 times 16. So that's 4 over 3x minus 16 over 3. B is 1/6 times 11 plus 3x. That's 1/6 times 11 plus 1/6 times 3x. So over here we're going to get 11 over 6 plus 3 over 6x. But 3 over 6 reduces because 3 is 3 times 1 and 6 is 3 times 2. And 3 divided by 3 is 1. So we get 11 over 6 plus 1/2 x. Alright, here's another fun one. Here's a little kind of a shortcut you can take. You want to see a shortcut? I'll show you a shortcut. Look at from this step here down to this step here. 4 over 3x minus 16 over 3. You can basically just break apart the fraction under the same denominator. Take a look at this fraction and this step. 11 over 6 plus 3 over 6x. So our shortcut can be this: 15 over 12 plus 6 over 12 x. 6 over 12 is going to reduce. also 15 over 12 is going to reduce. 15 is 3 times 5, and 12 is 3 times 4. And 3 divided by 3 is 1. 6 is 1 times 6, and 12 is 2 times 6. And 6 divided by 6 is 1. So I got 5 over 4 plus 1/2 x. Over here, 4 over 8 minus 2 over 8 x. 4 over 8 reduces. That's 1 times 4 over 2 times 4. 4 divided by 4 is 1. And then over here, this will reduce also. 1 times 2 over 4 times 2. And 2 divided by 2 is 1. So I got 1/2 minus 1/4 x. So we've said before that the multiplication property of -1 says that -1 times x is equal to -x. So if we see an expression such as this, negative this is the same as -1 times that. And now we can see that the -1 can distribute using the distributive property. So look at this example. What is the simplified form of negative 2y minus 3x? Well, that's the same as -1 times 2y minus 3x. And that's the same as, so there you got your -1. That's the same as -1 times 2y plus -1 times -3x. That was the distributive property. Now we can just simplify and we get -2y plus 3x. And the correct answer is C. So pause and see if you can simplify these bad boys. Push play when you're ready to see them done. Alright, A. This is -1 times a plus 5. -1 times a plus -1 times 5. And I get -a minus 5. So another way to think about it is that the negative sign gets distributed. -a, -5. So how do we do that here? Negative times negative is a positive x. And then negative times a positive is a -31. Negative times a positive is a -4x. Negative times a negative is a positive 12. Negative times a positive is a -6m. Negative times a negative is a positive 9n. So something that you might have been doing your whole life and not knowing you were using the distributive property to do it is sometimes we use the distributive property in our heads when we're doing multiplication. So I'll show you an example of what that looks like. Here's some deli sandwiches that cost $4.95 each. What's the total cost of 8 sandwiches? Okay, so I know sandwiches are $4.95. I'm buying 8 of them. I need to know the total cost of 8 sandwiches. Here's the plan. I'm going to think about $4.95 as being a difference and use the distributive property. So in real life, what you would say is you would say, well, this is almost $5, right? So if I do, it's what? It's 5 cents less than $5, and I'm going to multiply that by 8. So you would do 8 times 5 is 40, minus 8 times 5 cents is 40 cents. $40 minus 40 cents is a little easier than doing 4.95 times 8, and I'm going to do all this multiplication. So in your head you might have done this in the past. So here is it typed. 8 times 495 is the same as 8 times 5 minus 5 cents. Then distribute. 8 times 5, 8 times 5 cents. $40 minus 40 cents. 0.4 is the same as saying 40 cents. And then if you got $40 and you take away 40 cents, you got $39.60 left. So the total cost for 8 sandwiches is $39.60. That's a lot of money. Makes me want to go buy a sandwich. Of course, Subway makes it easy, right? It's just $5, no tax, unless you get a hot sandwich. Then there's tax. But I purposely don't get a hot sandwich so I don't have to pay tax, because I like paying $5 even. It's fun. So, see if you can figure out number 4. Push play. Well, first push pause, then push play when you're ready to see the solution. Alright, so Julia commutes to work on the train 4 times each week. A round-trip ticket costs $7.25. What is her weekly cost for tickets? Alright, so I'm doing 4 of these tickets, and each one is $7 plus 25 cents. So then I'm going to use the distributive property. 4 times 7 plus 4 times 25 cents. 4 times 7 is $28. 4 times 25 cents is $1. So that is $29. And you may wish to know that the secret code phrase for this lesson is Imagine Dragons. So we can simplify algebraic expressions by combining the parts of the expression that are alike. And the parts in expressions we call terms. Terms are made up of a number, a variable, or the product of a number and one or more variable. A term looks like this. That's a term. That's a term. That's a term. That's a term. And the sign kind of goes along with the term. So the term here is actually negative 5ab. The term here is positive 3b. The term here is negative 12. A constant term is a term that has no variable. We call it constant because it doesn't change. This term is constantly going to be negative 12. This term is going to change depending on what b is. A coefficient is the numerical factor of a term. So negative 12, we would call that the constant coefficient. 3, we would call that the coefficient of b. The coefficient of the term with AB, we would say that coefficient is negative 5. And the coefficient of the a squared term is 6. Alright, so let's take a look at this expression. The coefficients are 6, negative 5, 3, and negative 12 is the constant coefficient. The terms are 6a squared, negative 5ab, 3b, and negative 12. Like terms are terms that have the same variable factors. They have to have the same variable to the same power. So, are these like terms? What are the variable factors? A and A. Are they like terms? You know it. What about these guys? 4x squared and 12x squared. The variable factors are x squared and x squared. Are they like terms? C. What about here? 6ab and negative 2a. What are the variable factors? AB and A. Do those match exactly? No, so they're not like terms. xy squared and x squared y. They don't have, the coefficients are both 1 here. So are these exactly the same? This one has an x and then y times y. This has x times x and only one y. So these are not like terms. Alright, here's an important fact. An algebraic expression in simplest form has no like terms and no parentheses. So simplest form, no like terms, no parentheses. This is not simplified because I have parentheses and I have like terms. This is simplified because I have no parentheses and no like terms. And we can use the distributive property to help combine like terms. Let's take a look at how that works. 8x squared plus 2x squared. We can think about the distributive property backwards by saying that this is x squared times 8 plus 2. So if I have two like terms, I can say this is like 8x squareds plus 2x squareds, or I can say, let's put the coefficients out here. 8 plus 2 is 10, so this is 10x squared. 8x squared plus 2x squared, 10x squared. How about this guy? So, if we rewrite it as a sum, remember subtraction is just adding the opposite. So minus 3 is plus negative 3. Minus 3x is plus negative 3x. Now we can use the commutative property to move the x's by the other like terms, and the constants are like terms. And we use the distributive property to put the coefficients together. 5 minus 3 are the coefficients of x. So 5 minus 3 is 2. So we get 2x plus 6y, and then negative 3 plus 4 is 1. No like terms, no parentheses, so this is in simplest form. Alright, pause and see if you can do this one. Alright, so for A, 3y minus y. So the multiplicative negative 1 property thing says that this can be negative 1y. The distributive property says 3 minus 1 times y, and then 3 minus 1 is 2, so that's 2y. For B, negative 7m n to the fourth minus 5m n to the fourth. Those are like terms because they both have m and n to the fourth. So I can use the distributive property and say negative 7 minus 5 times m n to the fourth. And that is negative 12 mn to the fourth. C. Let's see. 7y cubed z minus 6yz cubed plus 1y cubed z. My like terms are the ones with the y cubed z. So I can use the... Okay, so first, in order to use the commutative property, I have to make everything addition. So plus negative 6yz cubed plus 1y cubed z. You don't have to write the 1, but it's easier to see when I do the 7 plus 1 that there really was one of these. So commutative property says I can change the order of addition. So plus 1y cubed z plus negative 6yz cubed. And now distributive property says I can put 7 plus 1 times y cubed z minus 6yz cubed, and 7 plus 1 is 8. So I got 8y cubed z minus 6yz cubed. No more like terms and no parentheses, so this is simplest form. D, can you simplify 8x squared minus 2x to the fourth minus 2x plus 2 plus xy any further? And the answer is only if we have like terms. Do we have any like terms? X squared. Do we have any other x squareds? No. X to the fourth. Do we have any other x to the fourths? No. X. Do we have any other terms with just x? No. Constant. Do we have any other constants? No. XY. Do we have any other terms with XY? No. So can you simplify this? No. Alright, we're done with lesson 1.7. work on the practice problems for 1.7. You got the answers to know if you're doing them right. Make sure you do those before you try taking any quizzes and before you do the formal write-up. But you know you need to get clearance after your formal write-up to take the quiz anyway, don't you? All right, talk to you later. Bye.